Today on the Future Podcast, we got Nico, the most private man in the Solana blockchain. Welcome to the show, sir.
Yeah, thanks for having me.
Actually, I guess that's baloney considering you're doxing yourself, so maybe you're not the most private, but we'll get into that. Well, thanks for coming on. Why don't you give me and the listeners a background kind of to yourself, how you got into crypto, and then of course, what got you to Arcium?
Yeah, sounds great. Yeah, so myself, I got into crypto all the way back in 2016 or 2015, something around that. And the way I got into it was actually through a use case that has nothing to do with crypto. So basically, I was in high school at the time, and I wanted to build a carpooling app, but I was super broke. And so basically, I looked up and I didn't know anything about coding. So I was like, okay, so to build a carpooling app, I need a server. And I basically checked online and I saw, okay, server costs like, $50 a month or something at the time. And for me, that was a lot of money back then. And so I was like, okay, what other solutions exist? And so I was just Googling around and I was like, decentralized, run on other people's computers, whatever. And through that, by complete coincidence, stumbled upon the Ethereum yellow paper at the time. And so I read that. Obviously, it didn't work for my carpooling solution, but I just thought, wow, this is super cool. This, ability to be able to run computations in a completely trustless way, combined with money especially. And so started, getting more interested in that. And basically after that, I did an internship at a company that was called Rivets, which was essentially key management solution, which allowed to kind of like the Solana saga does today, using secure enclaves,
Okay.
manage your private keys for inside of phones. So learned a ton of stuff about not just crypto back then, but actually both sides of crypto, basically cryptography and cryptocurrency. So the blockchain part and the security part. Got even more interested in it, and specifically the intersection of those two. So yeah, worked there for a couple of years, then went off to uni. Yeah, focused even more on that, and basically met my co-founders there as well. And yeah, now I'm here. So yeah, that's a quick
Dude,
background on me.
that was sweet. Did you finish university before landing a crypto job?
No. No, I
Just
guess
honestly, yeah, it's the answer I wanted to hear.
yeah, I guess I couldn't wait, I guess. Yeah.
These people are being rugged. Bad metadata. Their treasury is being drained. Pixelated crab NFTs are no longer the hip thing. The dev has disappeared. If this happens to you or your loved ones, relax. The Future DAO is here to save you with their newfangled token migrator tool.
I just called them.
I put the old token in.
And I got a new one and a fundraise out.
Now look at these people. They've been unrugged by Future DAO, and they've never been happier.
And it was so easy.
The Future DAO. For a better future.
I mean, I get it, man. Like the amount of, coders, developers out there that don't finish degrees and then go on to build projects. Like, it's like you're outpacing, especially that many years ago. Was there that many good blockchain specific courses you could have taken anyway?
Not really. Like blockchain wise, there weren't that many courses, but I am happy that, I still went to uni for a couple of years. So that means I did get, because I do think it's important because although, like you said, like a lot of people drop out and a lot of people get into blockchain without having, a formal background. I think specifically for the field where I work in, it's good that I did go to uni for a couple of years to at least get the math background, which is, super helpful now that I'm working more of cryptography stuff. Because I think if I didn't have that background, learning all that stuff from scratch, although it's definitely possible, it would have been a bit harder because you actually have to bring yourself to sit down and learn and whatnot. So yeah, I think I'm pretty happy with the amount of uni that I still did in spite of that.
Talk to me about like the cryptography, like your role with Arcium. And then also tell me like, tell me about Yannick, how the guys that you met at uni for starting, what was formerly known as Elusive. And then like, tell me more about your job. I'm curious about what it is you do there.
Yeah, for sure. So I'm the CTO. So that means I'm, from a developer standpoint, very lucky because that means I get to do a lot of coding and less meetings. Yeah, so I mean, it's concretely what I do at Arcium on a day-to-day basis. It's just, writing code, designing the protocol, talking with our other GigaBrain devs. We're lucky to have some really smart guys discussing how to make the protocol better, design decisions, things like this. Yeah, so that's basically me. And regarding, how we got started, since you asked about that, about Yannick and whatnot. So I have 3 co-founders actually, Yannick, Julian, and Lucas. And the way we got started is also a little bit of a funny story. Like I went to uni together with Yannick and Julian, and Julian and I were at the time running this like blockchain club at the uni we were attending, and Yannick had just joined it. And so we decided to take him out for some lunch for some burritos, and just talk a little bit about, about blockchain. And at the time, this was like end of 2021 or so. At the time, the new and sexy blockchain was obviously Solana that everyone was talking about, and that everyone's still talking about, fortunately. And so we were telling Yannick all about it. We're like, yeah, this chain is so great. It's so fast. It's so efficient. There's great community, blah, blah, blah. It's nice to build on. And so basically after we got done eating, Yannick was like, oh, how about you pay your share of the burritos that we just ate using some Sol? Because that way I can have some in my wallet and then I can try it out and blah, blah, blah. And I was like, well, I'd rather not do that because then, if I do that, then you can like see all my past transactions, all my future transactions and so on. And that basically sort of sparked in our minds, like, privacy solutions obviously already existed, things like Zcash, for example. But why were they so like damn hard to use on one sense? And on the other hand, so much less convenient to use and less efficient than being built directly on the chain like Solana, for example. And yeah, that basically sparked us to build an initial prototype of, at the time, what was elusive, using ZK for doing private payments, which we then built out over the next couple months. And then I remember it was the Solana Miami conference, like spring of 2022, where we actually posted on Twitter, got a little bit of attention. The Solana Foundation said, hey, you guys should present at our hackathon. We ended up going there, presenting it, thinking maybe like 1 or 2 people might think it's cool. And yeah, I still remember this, like we presented it and that got a standing ovation. And that basically told us, holy shit, like this is something that people truly care about and is worth pursuing, more seriously. And yeah, that's basically how we got started. And yeah, at that conference also met Lucas, our 4th co-founder.
That is awesome. What a good story, and such a good segue too. So for me and for the listener, when put Arcium into the Solana stack, because you brought up privacy and that being a reason, and like I completely understand. You want to go send somebody a transaction, and you got to think, okay, well, which wallet do I want to send from? And then you're thinking like, is that wallet, have I sent between those wallets? And so which one is my de facto send? And it's like, I totally get it. So talk to me about what Arcium is. Is it a layer 2? I know you said that elusive was the K, and it sounds like you pivoted. Run it through.
Yeah, for sure. So Arcium is what we call a confidential compute network. And concretely what this means is encrypted programs directly on Solana. So basically what this means is that we basically say the state and consensus and basically most things are still managed by Solana directly. The only thing that we change is that execution is handled by Arcium. So concretely, what does that mean? So that basically means we can have a smart contract just like we do, using normal Solana, using Anchor and whatnot. And now using Arcium, you can basically say, I have these accounts that belong to my smart contract. But this specific account here that manages a certain amount of data that I want to keep hidden, I can keep this encrypted. And whenever I want to access this, basically instead of saying, hey, Solana, please execute a certain transaction on this piece of state, you basically say, hey, Arcium, please execute a transaction on this piece of state. And the way the lifecycle works then, I think that might help to make it understand a little bit better. It's a little bit similar to how callbacks work back in the day with JavaScript for the little bit more technical people. In the sense that what you basically do is, let's say you have a smart contract that has an encrypted account. You basically tell Arcium, you tell it on the Solana blockchain, hey, please take this account and compute a certain computation on the encrypted state. Basically, then Arcium is a off-chain network that then computes some transaction. And then once it has the output, it submits another transaction to the Solana blockchain saying, hey, I'm done computing this. This is the encrypted outputs, and optionally with some additional decrypted output. And then your smart contract basically just handles the rest like it normally would on Solana. So that's basically the high-level idea of what Arcium is and how it works.
Talk to me from a user standpoint, how you would interact. Like, are you still going to be able to use your backpack or your Solflare to be able to interact? Like, how does that look?
Yeah, for sure. So that's something actually that was super important to us because as mentioned all the way back with that Burrito story, like one thing that inherently we realize is kind of a problem with privacy on blockchains is that you always have these terrible trade-offs in the sense that you have to say, do I want privacy or do I want like a million other things that are really great, like, performance, cost, blah, blah, blah. So essentially for us, the design philosophy was always that it should be as close as possible to interacting with a normal program. And that's exactly how it's going to work in this sense too. So the idea would really be that you have some developer build a smart contract, for example, in, let's say, an encrypted order book, whereby you can submit orders, those get encrypted so that people can't see what's being bought and what's being sold. And the way you would interact with it would be just like with a normal Solana program. So it means you'd have your normal front end like you frequently do. You connect your backpack or Solflare or whatever wallet to it. You click a certain button that says, trade. And then everything else happens under the hood. Basically, it submits an encrypted order, the encrypted order book smart contract, and then tells Arcium, hey, please find matches within these encrypted orders. And if one is found, the trade is executed and, you get whichever token you were trying to buy.
That's cool. For that specific purpose, buying via limit order, could the person use the Arcium stack? So you submit your off-chain order, but you can be filled by an on-chain order. Like, can the other side be non-privacy, or does it have to be matched privacy to privacy?
That really depends, because as mentioned with Arcium, the idea is really that we take care of allowing you to have private state in general. So that means, if you're a developer, you can do whichever you want. You can build a fully private dark pool where it's only private and private orders, or you can do a sort of hybrid model. So, it's up to what developers want to build with it.
That's cool. So the idea from you guys is like, and Solana does composability so well. Like, you have Sanctum, having LSTs embedded inside Jupyter. Is the idea for you guys that Solana dApp builder could input an Arcium layer that's like privacy mode, and if you turn on privacy mode in your dApp, then it starts to route through Arcium? That sort of like the goal?
Kind of. I think in the sense of keeping composability as good as possible, that's definitely the goal. But in terms of like how it actually looks from a developer standpoint, is basically that, we'd have an SDK, which would be sort of a crate that you can import into Anchor normally. And then, if you write your Anchor code for developers, you basically know that you define certain accounts that basically say how your state is managed. And using the Arcium crate, what you can basically then say is you say, okay, I have these accounts that are completely normal Solana accounts, but I have this or multiple specific other accounts that are encrypted. But outside of that, as a developer, ideally, you shouldn't really have to think about much more than that.
That's cool. Nice. All right. Let's talk about some use cases for this. You gave me one with private limit orders on DeFi, which immediately made me think of DCAs. Like, my God, I would love to submit private DCAs so they don't get picked off. What about like in the areas? I know your website mentions Deepin, AI, and healthcare. Give the users and me some examples.
Yeah, for sure. Although I think I want to expand on the DeFi one a little bit more, because I think there's some more interesting stuff to say about that. Which is
right.
dark pools in general. Because you said, for example, DCA is one thing that it's cool for, but just some other reasons that we think it's super interesting as well is specifically MEV protection. Because right now the reason that, basically on-chain trading is awesome, but there's a reason that unfortunately still most spot volume, at least for cryptocurrencies, is still routed through Binance, Coinbase, Bybit, whatever, these centralized exchanges, which is basically that on-chain you unfortunately have, especially if you're a large trader, a lot of slippage on one hand, and on the other hand, a lot of price fading. And what I mean by price fading is basically that if you have an order book, and this is, a fully lit order book where every order is visible, and let's say there's a market for Bonk Sol, for example, and you come in and you say, hey, I want to buy $10 million of Bonk. And then basically everyone that currently has their sell order inside of the order book might see this either already in the mempool, or, mempool in Solana, basically if there's something like this from Jito, and would say, oh shit, let me take out my sell order, because I know that the second that this guy's huge buy order here is going to get filled, the price is going to spike, and I can sell my Bonk for something higher. And something vice versa always exists if you're selling. Like, if you see there's a huge sell order coming up in the order book, you probably don't want to buy right then. You'd rather have that order get filled first, because that's going to drop the price, and then only buy afterwards. Which means that if you're a whale, or have a bit more size, it's quite difficult to trade without, having these types of problems. Of course, copy trading and stuff like this is a problem with that as well. Yeah, so for that reason, we do think that, encrypted order books, so for trading, is something really interesting. And similar principles apply as well for pretty much everything in DeFi, be it perps, lending, whatever. So DeFi is probably one of the ones that we're most interested about. But yeah, as you mentioned, some other stuff that we have on our website as well is, on one hand, Deepin. The reason that we think Deepin is interesting as well is for a bit of a different reason than this, which is that if you look at most Deepin projects today, most of them only leverage blockchain for essentially paying out rewards for Deepin participants, which is awesome. However, actually evaluating the data and, making sense of it and making something useful out of it, be it, for example, in the case of a Hive Mapper, or Peak is another one that collects, I think, noise data or something like this. This is usually done on centralized servers, basically for two main reasons. One of them is, efficiency to some extent, but the other one, I think more important, is privacy. Because if you're, collecting data, especially from the real world, you always run the risk of maybe not getting sued, but like getting in some kind of problem if you accidentally leak some data that's private or confidential or whatever. So it means you need to first put it on a central server, clean it to some extent, or do this on the edge like HiveMapper does, because there is really a way to do this on-chain directly, which then, of course, the consequence of that is that it introduces trust issues, because you have to trust, okay, is that server actually, not censoring certain people or I don't know what. Whereas if you could execute directly on the chain, you wouldn't have this problem. And this is basically what Arcium solves here, that we can say you can have a fully trustless computation environment living directly on the blockchain with predefined rules that we can be sure are enforced correctly, because, that's the way smart contracts written on chain. But still have everyone's privacy and data guarantees and whatever kept secure. So that's sort of the bull case for Deepin with Arcium.
And so you mentioned before about an off-chain component of Arcium.
Yeah.
Where is the off-chain component exist with that specific reference?
Yeah, so with Arcium, you're always going to have an off-chain component. And the reason for that is that the way we actually, because as mentioned, we have encrypted smart contracts, and on that encrypted state, you can compute certain predefined functions. The problem is obviously that Solana, unfortunately, doesn't support multi-party computation, which is the technology that we use to compute directly on encrypted data. So we can't do this directly on-chain. So instead, what we do is we have a network of nodes that computes these multi-party computations off-chain and then submit the result back on-chain. And the way we can basically be sure that these nodes aren't doing some, nonsense or submitting wrong data or whatever is essentially through interesting cryptography, whereby we can say we use something called BDOS, which is the MPC protocol that we use with cheater detection, which means that if any node is detected to say, okay, it's submitting wrong data or computing stuff wrong, the other nodes can basically tattletale on it on chain. And then basically, if that happens, there's consensus for this, the node risks getting slashed or being punished in some other manner. So through this, we can have, very high trust that the nodes are not cheating only through cryptography and not having to trust certain actors.
That's cool. And do you guys, I'm sure this is in the documentation, like minimum number of nodes? Are you trying to grow nodes? What is that looking like before we get into like the AI and healthcare?
Yeah, for sure. That's actually a really interesting question, because that actually ties in, if we can take one step back, of like our decision of how we designed Arcium in the first place. Because one question that we get semi-frequently is, why didn't you guys build this as an L2? Because there's some other projects that exist currently that, are doing like private state as well. But the path that they chose to do is doing an L2. And the reason for that is that MPC or the other technologies that you can use, for example, FHE, logically aren't as fast as normal computations. And so what that consequently means is that if we would do an L2, that means we would have essentially, even in the case of Solana, we'd need all our nodes to, on one hand, have consensus on what the current state of the entire network is. And on the other hand, they'd be limited because essentially, if you have an L2 or, a blockchain in general, each node to some extent always has to process or reprocess every block to essentially make sure that there wasn't something incorrect within that given block, which inherently limits your throughput. Which means if we had done L2 directly on Solana, it would just be, significantly slower than Solana currently is. And of course, would also lead to having people to bridge and stuff like that, which basically makes composability and performance, which is, for me personally, my two favorite things about Solana, significantly worse, which is something that we didn't want to do. So the network,
Cool. Go ahead.
And so basically the system that we came up with, we think is quite cool, because it essentially allows us to minimize impact on both composability by, being directly on the L1, and performance through our architecture. Because what we can then say is, since consensus and state is managed by Solana directly, our nodes only have to worry about performing certain computations, but they don't have to worry about keeping track of the entire state of the entire chain at all times. Which then means we can say for one given smart contract, we don't need to have the entire network of nodes actually compute a certain computation for that. Let's say if we have our encrypted order book, we don't need the entire network of Arcium nodes to compute everything for that specific smart contract that has the encrypted order book. Instead, we can say we have one cluster of nodes that computes the execution on that specific encrypted smart contract. And if there's a different encrypted smart contract doing, AI, Deepin, what have you, we can have a completely separate cluster of nodes that then computes on that specific smart contract, which means that we're not really limited by essentially the only thing that we're limited by is the scalability of the underlying network. So, if the underlying network can process a bunch of different smart contracts, we can have, in theory, tons of different clusters for each of those specific smart contracts, which is a really long way to answer questions about us looking for nodes as yes. As, ideally, we'd want to have lots of nodes so that we can have tons of performance, whereby we can have ideally dedicated clusters for each smart contract, which allows us to have the maximum amount of scalability and be as parallelized as possible.
That's legit. Okay, can you describe multi-party compute in a simple manner?
Yeah, for sure. So multi-party computation, I think the name already explains it pretty good, is that you say you have n different parties, and they all have secret values, and together, without trusting a centralized party, they want to compute something based on those secret values. So I think it's best to think about it using an example. So what we use is something called additive secret sharing, which is a certain type of MPC. And let's say we have the example of, 3 people, Alice, Bob, and Charlie, and they each have a salary, and they want to come together, and they want to compute their average salary, but they don't want to reveal their salary to each other because they want to keep that private. So how can they do that? What they can do is, essentially using additive secret sharing, is they can do this in 3 steps. The first one is secret sharing. So what they do is they take each of their salaries and split it up into 3 different pieces that add up to their total salary. So for example, let's say if Alice has a salary of $90, Bob has one of 60, and Charlie has one of 30. Each of them would split it up into separate pieces. So Alice has 90,
Okay.
so she could split it up in 50, 30, 10, for example. Bob has 60, so he could do 25, 25, 10. And Charlie has 30, so he could do 10, 10, 10, for example. So each of them split up into 3 pieces that are not necessarily equal sized. Then the next step is you take each of these secrets and you distribute them one from each to each other. So in the case of Alice, she split it up into 50, 30, and 10. So that means we could say she keeps 50 for herself, gives 30 to Bob, and 10 to Charlie. And basically Bob does the same thing, keeps 25 to himself, 25 to Alice, 10 to Charlie, and Charlie gives 10 to himself, 10 to Alice, 10 to Bob. So that means, just to keep track of the numbers, Alice now would have 50 from herself, 25 from Bob, and 10 from Charlie. And now the final step is you do exactly the same computation that you'd normally do for calculating an average, except you do it in a distributed manner. So basically what you normally do to compute an average of the 3 salaries is you sum up the 3 salaries and you divide them by 3. So now Alice, Bob, and Charlie are going to do exactly that. So Alice has, 50 from herself, 25 from Bob, and 10 from Charlie. So she adds these up, gets 85. Bob has, I think it was 30 from Alice, 25 from himself, 10 from Charlie, adds these up, gets 65. And Charlie has 10 from everyone, so he adds this up and gets 30. So that means Alice now locally computed 85, Bob locally computed 65, and Charlie locally computed 30. And now the final step, what you do is called opening, which is where you essentially combine all these values back together and decrypt them, or at least reveal the final answer. So that means 85 plus 65 plus 30 makes 180, if I'm not mistaken.
Yep.
Exactly. And so it means 180, if we now divide that by 3, which is what you'd normally do for salaries, equals 60, which is the correct answer. And so that means through this cool protocol, Alice, Bob, and Charlie were able to compute what the average of their salary is without, as you noticed, ever actually telling each other what their concrete salary is. And this is basically what we make use of in MPC. Of course, there's, this is really simplified. There's other stuff like what you do if they submit the wrong values or compute something wrong or whatever. So there's, a bit more complexity to this. But the main idea is basically this, saying we split up secrets, compute on them, and only essentially put them back together to get results, but don't ever reveal what the intermediary values or what the initial secret values are. And using this, you can basically build what we're doing at Arcium.
That is super sick. And I guess when things start on chain, it's harder for people to lie because it would usually have to be something in their wallet. And so they couldn't submit improper details when it literally lives on chain.
That's true. Although in this case, it's a little bit more complicated because since the values are, split up to some extent, you usually don't directly know what the initial value is. So, for the case of Alice, she has a salary of 90, but let's say no one actually knows this. There's not that much stopping her from, telling to Bob and Charlie, okay, you guys both take 100 and I'll keep 100 for myself. And by that, pretending she has 300. But yeah, I think explaining how you get around those specific things is a little bit outside the scope of this podcast. But yeah.
I already got a good enough math lesson. We can't get into philosophy. That would just be too much. All right. Why don't we carry on with the list? Tell me about AI in healthcare and how that's good to your guys'.
Yeah, for sure. So yeah, I think those two correlate to some extent. Actually, leads in pretty good with explaining what NPC was just now. Because in AI and healthcare, you have essentially the same problem, just a lot more complicated to some extent. Because you frequently might have the case that, let's say you have, I don't know, 10 hospitals. They all have patient data about their patients, and now they want to find out, okay, so if a patient has, I don't know, this temperature and whatever other attributes might exist for a patient, what's the probability of them having this sickness, or what's the probability of having that sickness? Basically, want to train a model based on patient data that basically reveals what sickness they might have or something like this. Now, if you would do this conventionally, let's think outside of the realm of blockchain. If you want to do this conventionally, what might your approach be? Generally speaking, you giving your patient data to 9 other hospitals is unlikely because, already trusting one other hospital with your patient data is quite the big risk because of data protection laws and whatnot. 9 other ones, the chance that one of them leaks it or doesn't keep it secure or whatever is quite high. So it's unlikely that might do that. So instead, what you might consider is that you say, okay, we find some centralized party that we trust very much. So we all give our data to this specific person and they compute it for us. And although this is better than the ones of having to trust 9 different parties, in this sense, this is still not ideal because you have to trust one specific party with everyone's data. And you also have to make sure that they're actually computing the function that you want and not computing something completely different, keeping this data for themselves, and a bunch of other problems. So using MPC, we can solve this quite elegantly because you can still think of it in the same way as, wanting to compute the average salary as wanting to, train an AI model, because at the end of the day, it's just math, even though it's more complicated in that sense. And using MPC, we can really say, okay, we have our 10 hospitals. They have, secret patient data, and they want to train an AI model with it. And so using additive secret sharing, we can do exactly that. You can train AI models using data from different parties that don't trust each other, but still, bring that data together to extract something useful from it without having to, trust each other. So yeah, we think that's quite cool. Actually, on that note, one other thing I just thought of that's interesting as well is that, for us being in blockchain, frequently you sort of have this thing, or so, at least I have this to some extent as well. I have this bias of always being like, oh, of course it has to be on the chain. Everything's better if it's on the chain. But, for example, with this example of saying AI in healthcare, someone who is not as much in blockchain might ask themselves, wait, but what do you need the blockchain for in this specific case? Couldn't the hospitals just do this without being on the blockchain in the first place? And this actually brings it back to what I was talking about with cheater detection earlier. Because if you don't have a blockchain, you actually run into another trust issue here, which is what happens if one of the parties that submitted the patient data purposefully submits wrong information or tries to sabotage the operation in some other manner. In the traditional world, you might have some other recourse to this, but depending on your situation, not necessarily. Whereas in the blockchain world, with our MPC algorithm, we have cheater detection, which means that all participants who actually choose to participate in this computation are directly incentivized, monetarily incentivized, to actually compute the correct data, because otherwise, they risk being cheater detected and consequently slashed, which is something that, a blockchain is extremely useful to do, because slashing in, outside of the on-chain world is much more difficult to implement because of legal or whatever. Whereas in blockchains, we can easily do this and have truly trustless multi-party computation.
I think you guys are, especially with the healthcare side, you're ahead of the narrative, if I may. But I think it's a very important sector, and I hope that over the coming years and to the next decade, we see big changes in how scientific paper, scientific reviews, all of these things are done, because trust is the biggest thing there. And so, I'm stoked to see you guys working on it. And if I may, you probably can't, but I'm going to ask anyway. Can you tell me about, teams or projects that are building within the DeFi Deepin AI healthcare? Like, are you guys getting approached from a lot of different protocols to say, hey, like we wanna try your guys' SDK? I'm just curious. You probably can't tell me about that.
Yeah, for sure. Yeah, no, I don't think I can tell you like any concrete names at the moment yet. But yeah, I mean, for now, most of the interest is coming from DeFi because, as you said, in that sense, like we are, yeah, I guess a little bit ahead of the narrative to some extent. But I don't think we are with DeFi. Like DeFi is as hot as ever. So specifically in that, like there's tons of people who are interested in building, dark pools. And as you said, because dark pools isn't just like one uniform thing. You already noticed yourself when you asked about order flow matching, for example. There's like 10 million different ways that you can build that, each with different pros and cons, just like with normal on-chain order books. So yeah, in that sense, we're really excited about tons of different people thinking of tons of cool stuff to build with it that we wouldn't have thought of ourselves even.
Super cool. Super cool. Yeah, and Deepin is one that I really love, the Hive Mapper team. Competition. I know a bit about Genesis Go and their Shadow Drive, and I know it's mostly storage based. Are you aware, like, are they a competitor in terms of like running a privacy based network? Is that? And then Light Protocol, they're doing like the L2 ZK route, right?
Yeah, so in the case of Genesis Go, I wouldn't consider them a competitor because I think the approach is quite different there. Genesis Go is really all about, storing data and doing that in a secure manner. And then, they're a great team, doing some great stuff. For us, it's really more about saying, we have encrypted state. How do we actually compute functions on top of that encrypted state? The case of how is that encrypted state managed and stuff like this, that would delegate directly to Solana. So in theory, you could even build something that utilizes both Genesis Go and Arcium, where you basically say, okay, in my smart contract, I have some state, I store this in Genesis Go, keep it encrypted there, blah, blah, blah. And then when it comes time to, compute something on my encrypted state, I load it into an account on Solana and I tell Arcium, hey, please compute something on this encrypted state. And then when it's done, you put it back into Genesis Go. So I think those are actually complementary to some extent.
That is what Hive Mapper needs. They were chit-chatting with Filecoin a while ago, and I was like, don't you dare. Let's keep this Solana native. So listen, Hive Mapper, Ariel, if you're listening to this, we still have a podcast to do. You need to be speaking to Arcium, and you need to be speaking to Genesis Go for your storage. Okay, there's my plug. Carry on.
Perfect. Yeah. In the case of Light Protocol, like, I think we were a bit more, competitive to them back when we were still building out Elusive because our products were more similar. I think at this point, both Light Protocol and us has, changed our focus to some extent. In the sense that, I mean, I don't follow Light Protocol as closely, so I might get corrected for this, but if I understand correctly, their main thing right now is more so about, ZK compression for data with the new rent returning and whatnot on Solana. And of course, providing data availability for potential L2s building on Solana, and not as much the privacy part anymore. But I think this is also an interesting, segue into why we actually chose to build with MPC over ZK specifically, because we're still doing, privacy in that sense. Which is that with ZK, the reason we switched to doing MPC, because with Elusive we were using ZK just like Light Protocol, except we were using it for privacy, is that with ZK you always sort of have this problem that you can't have shared private states. And concretely what that means is that, the main way that ZK basically works is that you really say, okay, I have some encrypted or some hash or some, secret data. And because I know what the pre-image, like the unencrypted version of that data looks like on chain, I can generate a ZK proof where I basically say, hey, here's a proof that I know what the decrypted data looks like. And because I proved that I know what the decrypted data looks like, you can allow me to edit it or replace it with something else or perform some action. And this is great if you, think in a single actor model. But if you think in a multi-actor model, which is pretty much always the case on chain, this doesn't work. For example, let's say the encrypted order books. You have an encrypted order book, and let's say you submitted an order inside of there that's encrypted, and I submit an order inside of there that's also encrypted. Now, let's say someone comes along and says, okay, now we want to find out if Nico and Dirt's orders are matching, if the trade should be performed. With ZK, that's extremely difficult, if not impossible to do, generally speaking. Reason being that there isn't, for me, I encrypted it with my key or with my whatever. You encrypted it with your key. So how can I generate a proof about, oh, there's a match here if I don't know what your pre-image looks like, and vice versa, how can you generate a proof for that if you don't know what my pre-image looks like? The only way that that would work is that there would need to be some single actor that knows what the encryption key for everything looks like. But then again, at that point, it's like, we're using, a smart contract in the first place. So yeah.
Interesting. That's really cool. I wanted to ask before when you were talking about the nodes
Mhm.
and, speed and security. Is there any security trade-off with this setup via VK or layer 2? Because I know you said like the security still falls to Solana, and I meant to ask, there's not like Arcium will never be used as a gas token. Solana will always be the gas token. Is that right?
Yeah.
Because it's not an L2, which is parallel state. So is there a security trade-off at all in this model?
Yeah, so yeah, there's, pretty much in everything cryptography, you always have security trade-off to some extent. So in this case as well, there is a small one. There's not necessarily a security trade-off in terms of like the custody of your funds or something like this, but there's a security trade-off in, how privacy is managed. And this is basically that, as mentioned, multi-party computation works in the sense that you have n different actors that basically hold a sharded key with which the state is encrypted. And as long as they, follow the protocol for the most part, which means that essentially each Arcium program under the hood, what it looks like in the case of an encrypted order book, is that you say, okay, please perform a computation that using local computations, so it means not actually reconstructing the key, does decrypt the state, perform a certain action on it, and basically re-encrypt the state with the state changes having taken place. And then the only thing that you actually output by putting it back together, like we did in the case of the salary sharing, is the new state in that sense. However, the only security trade-off that you basically have there is that if every single actor basically comes together and reveals their part of this encryption key to one another, they would be able to decrypt the on-chain state. However, this is, something that you always have when you encrypt something. You have to keep the key somewhere. And the type of MPC protocol that we use is dishonest majority. And what that basically means is that unlike many, Byzantine fault tolerance protocols, for example, where you say if at least 50%, 51%, or if 66% of the network is corrupt, then you have a big problem. In our case, it's really if even one actor is still honest, then everything works fine. And we think that this is a great security trade-off for the following reason. Let's say you're, Dirt, tomorrow you record this podcast and you're like, wow, this is so awesome. Let me build an encrypted order book. What you could do in that sense is you could say, okay, but I want to be 100% sure that no one can ever decrypt this unless it's according to certain rules. And I don't want to have these, dishonest majority trust assumptions. In this case, what you can do is you can say, okay, I'm going to build my encrypted order book, and I'm going to put a constraint in there that basically says every cluster that computes encrypted state on my encrypted order book has to include the Arcium node that I myself am running. And through that sense, you can basically say, since I always know that my own node is going to be honest, I can be 100% sure that even if the other nodes mess around, they won't ever be able to decrypt it because I know my own node isn't going to do that. So yeah, in that sense,
they would need 100%
exactly
to open it. And if you're like, I'm never going to reveal it, even if they got 99, it wouldn't make a difference.
Exactly.
Cool.
So in that sense, we think, for developers, you have really high confidence, and you can have pretty much 100% confidence if you choose to run your own node. So yeah.
Wow, man, I've been today. Nice work. I'm gonna get close to wrapping it up. I saw in your Discord you guys had a test net. Do you have any dates for that? Any alpha for the community?
Yeah, so we don't have a concrete date for that announced just yet. However, you can expect it to be sometime this summer. And yeah, you should join our Discord or follow us on Twitter, and then you'll have all the latest updates. When that goes live.
Absolutely, I'll include those links. All right, before I wrap it up, is there anything else you want to say, Nico?
No, I think not directly. As you said, follow us on Twitter and check our Discord to keep up to date. And yeah, let's build the private future of Solana.
Ooh, well said. Okay, before I let you go, I always like to ask my guests one thing. What was it that you did to stay sane during the bear market that got you through touching grass, playing game, whatever it is? What's your thing, Nico?
My thing is foosball, so table soccer, actually. So I've been playing that ever since I was little, and it's one of my I don't know. It's like one of these like super random hobbies that's whenever like I meet someone in person, there's a foosball table around. Like it's my favorite thing to tell. Like I can confidently say I'm pretty cracked at foosball. So yeah, that's my thing.
Um, all right.
What about
Well,
you?
breakpoint. Breakpoint. Let's find a foosball table championship.
Yeah, for sure.
No spinnies, obviously.
Of course not.
That's so good. Man, me. Nobody ever asked me. That's funny. God, what did it keep me sane aside from just sitting at the computer all day? Staying in shape. That was
Nice.
it. You know, working out, moving around, playing golf, somehow getting shittier at it. How about that? All right, dude. Thanks for coming on the podcast. Appreciate you.
Yeah, thanks for having me.
You
Bye.
betcha. Let me click the stop.